Yeah, now at least I have a link to YouTube video. Um,
Which is great.
I still don't see it playing on YouTube though.
I've got
Like
a link on Twitter actually, so maybe you can check.
maybe
Um,
oh, the link is different now.
oh,
Oh yeah, we are live. What I propose to do now is to update our links and Twitters and wherever. Let me send you a link in the private chat here.
okay.
Whoa. Oh, it tells me upgrade plan.
Yeah,
This
we
is
don't have a private
fascinating.
chat.
Okay, let's put it into studio chat, which is fine
Right.
too.
Okay. Right. So that's actually the active link, right? So,
Yet it is like we are there right now. Like we are live and so on. And while you're updating it, I will try to introduce myself again. Hello, everyone. After a couple of small technical problems, we are trying to go live again. Hopefully, you can see us, you can hear us, and well, and hopefully you were able to wait for 5 minutes for us because today is a special day. It's the first Friday of Advent of Code. And on the first Friday of Advent of Code, we get to talk about what happened in the last 6 days of Advent of Code in the first week. Usually, the first week of Advent, who knows what Advent of Code is? Um, should we explain?
I think we should. Well, I think most of our viewers do know what it is, but still, it would be nicer to explain. So,
But
yeah, yeah.
probably before explaining, if you already can, we can introduce ourselves again. Like, because we did it the last time, we didn't do it this time. Still no viewers, but well, we'll live with it. I'm Pasha. I'm developer advocate for BellSoft. In case if you don't know, BellSoft is a company standing behind Library GTK and Alpaca Linux. And if you're not a Java developer, you might be more interested in our Linux thing, very small Alpine-based product. In case if you're a Java developer, well, just the best JDK out there. And let me introduce my colleague and co-host, Kate Edelweiss. Do you want to say a couple of words about you?
Yeah, so my name is Catherine, or Cat for short. So I don't know why everybody calls me Cat. So I'm a developer advocate at BellSoft too, and I'm not going to repeat anything about the company. Right, so, but in case you forget where we work, there's a logo on my t-shirt, on Pasha's t-shirt, on the screen, and everywhere that you can see, there's a logo of BellSoft. Yeah.
Okay, was it your first time solving Advent of Code?
Yeah, you know, Pasha, this is a very interesting and unusual thing to me, and very exciting topic for me today because I have never previously solved any Advent of Code puzzles. I remember solving a couple of algorithmic exercises or problems while I was studying Java, which was 5 years ago or six even. So I can't even call myself an amateur. So that
Okay,
was very unusual to me.
which is fine. I mean, we all start somewhere. And I actually started solving Advent of Code puzzles like 5 years ago. Why is solving a process and not a result? Well, the thing is, it's advent of something. It means that, well, it started when the Christmas was coming. Currently, you cannot say that the Christmas is coming. Currently, it's holiday season is coming, which is also fine. And in expectation of the holiday season, we have starting from December 1st, one, actually two programming tasks every day. They're somehow related to the festive season. There is something about elves, or there is something about magic, there is something about deers, and well, a lot of things. But it's just a way to start learning programming, learn new things, learn new languages, learn new algorithms, and so on. And every year, it's not important how many years in a row I'm trying to solve all the puzzles in Advent of Code. Every year, I'm learning something new.
So
I,
how
I
many years have you actually been solving the
I
puzzles?
think I started in 2018.
Wow.
I think the whole thing started in 2015.
And
So yeah,
did you
I'm
solve
like
all
I
the
have
puzzles?
5 years behind, and I finished only two of these years. So I think it was 2023 and maybe 2022.
Right.
Usually tasks become too complicated. We should say that tasks become more complex almost every day. The complexity drops a little bit on the weekend, on weekends actually. Uh, Sometimes not. Sometimes it's tricky. Sometimes you wake up on Monday morning or on Sunday morning and you are like, well, it will take me 20 minutes. And then 3 hours down the line, you still didn't have your breakfast. You still didn't play with with your kids. You're just solving it. Well, to me, it happens more often than I would like to, and more often than I would like to admit, because I'm not too good in programming. Well, I
Um,
kind of know some basic algorithms, but when it becomes complicated, in 2019, to the end of the year, you were supposed to have written a huge virtual machine, actually, which is very interesting. Well, you start by a very basic thing, like you have this set of commands, execute it, and give the result. And this is simple, but then because all the commands are simple, they are like add two to previous number, I don't know, subtract something, multiply something, and that's all. Well, so you just do operations in a row in a simple for loop, and you give the result to that end of code. But
right.
then it becomes more complicated because suddenly there are jumps, there are ifs and elses, there are loops and so on, and you have to write, and sometimes there are tasks like, we have this program text, but you should fix it. You should find a mistake in it automatically, obviously. It's not like something you can do manually. You should find the mistake in it and replace it, fix it somehow. Replace one instruction with another so that program would execute correctly. And it was tricky. And I don't remember on which day, but I gave up. And I do not regret anything. I mean, I only have so much stamina. But probably these days I would be better.
Right. So because you have more experience or because you
Yes,
have more
probably yes. I
energy?
have more experience. I'm more familiar with my tools these days. I mean, I continue learning every day, and so my main languages are Java and Kotlin for many years. I still I published a tweet about it like a couple days ago that I just found that the assert statement that there is which exists in Java since Java 1.4 has a bit of syntax I wasn't aware of. Like you can write assert something, assert, then your expression, then you can put colon, and after the colon you can put a string which actually will be a message of error that assert will throw, which is very interesting. It means that somebody specifically designed this feature and it's absolutely not discoverable. Yeah, there is just no way to know that it is there. You know how I found it? I used my AI assistant in IDEA.
Mm-hmm.
Give me a second, Masha asked me some questions. Um,
Right, but
yeah,
guys, don't you worry. We are going to show you the puzzles, the solutions, and this assert statement that Pasha was talking about. We're actually going to show it to you too, and a couple of maybe new features that might be new to you and might be useful to you, not only in the context of solving algorithmic problems, but in your everyday work. Like, for instance, stream gatherers. That's a new feature in JDK, which is super cool. And well, Pasha has already found how to use it and to write, well, to write, I would say, gracious, well, more laconic, more concise, and gracious solutions to the puzzles.
Thank you so much. I still think that there is a lot of things I could improve probably, but I'm not running for perfect. I am usually running going for good enough. But probably we should jump.
Yeah,
Probably we should jump to our tasks.
yeah.
Do you want to show the first task, or should I
Yes,
do it?
with pleasure. Yeah. So let me just share my
We should
screen.
probably share the task itself
Yes,
first, right?
of course. Yes. Mm-hmm.
Nice.
Right. Okay. So here it is. Right. So um, there's a very very long description, right? So as Pasha has already said, all the tasks are wrapped into a beautiful story of well, Christmas trouble, so to say. And I don't know, like finding, in this case, finding somebody who could help Santa, well, do his stuff. And we're not going to delve into that kind of thing, right? So we are going to jump straight into the task. And what we have here is two lists of numbers, and that's, well, that's our first task. What we should do with them is that we should uh, pair up the numbers and measure how far apart they are. So, and we have to pair up the smallest number in the first row with the smallest number in the in the left list with the smallest number in the right list, right?
Or if
And
you use rows, you can say columns.
or columns, yeah, exactly, right. So and as you can see, we here is the example of what we should do, right? So we have here two columns, and the smallest column in the left is 1, right? And the smallest in the right is 2, right? 2, no, uh no, 3, sorry.
Three. I think it's
Yeah,
three.
and the distance between them is 2, right? And then we go on. So the second smallest number in the left column is 2. And the second smallest number in the right column is again 3, right? Because we have two threes. And the distance between them, right, is 1. And this way we should pair all these numbers, and then we should find the sum of the total distances between them, right? So that doesn't seem that tricky, right? So let's look at the solution. And here's mine. And Pasha has, well, his own. And also Pasha has the solutions in Kotlin. So I think we could share with our audience both Java and Kotlin. So, well, because if we have Kotlin enthusiasts, they will be pleased to see that. Okay, so let me just, can I make it larger somehow in the IDE? No, I think I can't. Right.
You can hit Command Shift A, I think, or something like that. Oh, you can hit triple Shift.
Triple shift.
Yes, and
Um,
now you can type presenter mode. Yes, enter presentation mode.
okay, great.
Here you
Right.
go.
Well, that's nice. That's a new feature.
Yeah, well, learning every day.
Every day.
It's the whole essence of Advent of Code.
Yeah, yeah, and that's beautiful actually, because you learn not only Java, but you find new things in, for example, IntelliJ IDEA.
Yep.
I'm not a very great expert on shortcuts in IntelliJ IDEA and hidden features, but Pasha is, well, bigger expert than I am, and he showed me a couple of useful things that I didn't know about, and that was so cool, really.
As Josh Long said, I know maybe only 1/10% of idea shortcuts and features. It's already something, but it's not much at
Oh
all.
yeah. All right, so what our task is, we have two basically large columns with strings, uh, with numbers, and it is presented as a string. So what we should do is that we should parse the string, right, and somehow filter the numbers into two lists in Java, right, to work
Yep.
with them. So we are starting with creating two lists with the first column and second column. That's just a simple array list, nothing fancy. We don't need anything fancy. And then we're using streams, right? So we have, again, we have this large string with numbers. And what we are going to do is that we are going to stream it, right? So we're going to stream the string, and we are going to split the string using Pasha, what's it called?
It's new line,
New line.
new line
Just
character.
new line. I thought there was some fancy name.
You can say line fit if you if you.
Okay. Right. So and now we have a stream of lines, right? Strings. They're still strings. And then what we are going to do is, oh God, I should stop using my mouse so much because it's just jumping out. Right, so what we are going to do now is we are going to split again these strings, little strings. Well, we're going to filter them, of course, in case there are some empty spaces we don't need. And then we are mapping the strings into integers, right? Because we have integers there. And then we're carrying in lists. And now we have a stream of lists, right? So each row was turned into a list with two numbers, right? And from there on, it's super easy, right? So we are using for each, and then we are adding the first, zero positioned element of our list into the first column, and the second element we're adding to the second column, right? And that's it. Now we have two collections of integers, our first column and our second column. And we are sorting them with a very convenient way, collection sort, right? And then they're going to be sorted from minimum to maximum. And after that, that's just a simple iteration, right? So we are going to take these lists, and we have first our sum, right? So we're going to use the 2. And first we're going to get the difference between the numbers, right? So the first element and the first element of the second column. And the ABS is a function that gives us the number without, well, gives us a positive number, right? So because it might be a minus, right? Because if the first column is like 3 and the second column is 4, so we get -1, but we only need the difference, right? The difference is 1. So that's what ABS does. And then we are adding that to our sum, right? And this way we are going to sum it all in just one cycle and return the sum. That's it. Doesn't seem that difficult, right?
Do you want to demonstrate how it works?
Yep. Just a sec, I'll find how to switch to another class.
You can always hit Command O,
Command O.
and
Right.
here you can put the name of the class.
If I remember. Oh, okay, this one. Yeah, so here it is. I was too lazy to to put the string into the, well,
In the file?
into the file. Yeah, but it's okay. That's one way of doing that, right? So that's a super long string, and we have our day 1, and we're going to print out the sum, and the sum is
Let's check it.
Yep. So I guess I should exit the presenter mode. How do I?
You can just hit Command Tab and switch to browser.
Right.
Yep.
Yep. It's my brother. Yeah. So right. So the answer was that.
Something very similar.
Yeah.
Something very similar.
Yeah. And that's it. Right. So well, that's the first task of the first day. And well, the most difficult thing was to understand what they want you to do, right? And then for me, well, I just had to remember how to parse this string into integers and put them into two different columns, right? So that's what just I had to remember. But then that's easy. Java does that for us by sorting the collection and just doing simple iteration, right? But then there is a part 2. So again, we have a list. That's the same list, but the task is a little bit different. And this time we need to figure out how often each number from the left list appears in the right list, right? So for instance, we have 3, and it appears 3 times in the right column, right?
Yeah.
So when we stated that, when we found that out, we need to calculate the similarity score. So what do? We add up each number in the left list after multiplying it by the number of times that number appears in the right list. Well, that's where my brain exploded, actually.
Why?
Well, because I didn't quite. Well, at first I didn't understand what they want me to do, right? But after seeing the example, I said, okay, 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 okay.
So what's wrong? Maybe it might be a piece of interesting feedback to Eric Wassel, who is the author of all these interesting puzzles. What's wrong with the description?
Well, it's just that. Okay, add up each number in the left list after multiplying it by the number of times that number appears in the left. It's just the sentence is just too long, and then when you get to the end of the sentence, you forget what there was at the beginning of the sentence. That's the stuff.
Okay, so it's more of a parsing issue. Maybe the description. So which form of the same, I don't know, of the same rule you would prefer to hear? Like, should you would you prefer to just treat simple instructions like for count how many times each number occurs on the right side, then for this number of times multiply it by this number on the left side?
Yeah.
To me it sounds, to me it's also complicated. I think that's actually why he has this example, like 3 multiplied by 3, 4 multiplied by 1, and he has very, very extended and prolonged explanations. The first number in the left list is 3. It appears in the
Mm-hmm.
right list 3 times, so the similarity score increases by 3. And well, I find it relatively simple to follow, isn't it?
Oh yes, yes, it is. So thanks God there are examples, because following the example is much easier to understand the instructions. Well, for me at least, right? So without the examples, that would have been for me much harder, I think,
I
to
see.
understand.
Yeah, fair enough.
Yeah. So as you can see, right? So what we are doing here, right? So we are multiplying, and we get 9, and 4 we encounter it's, well, the it's there. Oh yeah, once, yeah.
Once.
Right, so we multiply 4 by 1, we get 4, and then we get to the end of the list, and then we sum all these scores, right, to get the sum of all the scores. Right, so that's a little bit different, right? Okay. Let's see. Comment. That was day 1 still. Yeah, just part.
You can, yeah, I think it should be like the same line of code in the main class as the previous one, but with get some part two instead of get some part one.
Yeah, so
Yeah,
yeah, that's the same actually, right? So we have our columns again, but here there's a difference, right? So we are creating a hash map with integers, and first we are going to uh, sort the um, the numbers from
I'm sorry. May I
yeah,
interrupt you for a
yeah,
second? Let's maybe explain what does this hash map contain.
yeah.
What are the keys and what are the values?
um, right. So the um, the keys are uh,
So
Gosh, I forgot my own
the key
decision.
the key is the key is actually the number from the right column, and the value is the number of occurrences of this number in the right column, right?
Yeah, because so values can change, but keys don't change, right? And keys are unique, right?
Okay,
So
cool.
that's, yeah. Mm-hmm.
So then we have this for loop. What's in it?
Right. So we're searching whether our hash map already contains the number that we are looking for,
Mm-hmm.
right? And if it does, then we are adding one, right? Because we have encountered this number one more time. Yeah,
Exactly one time, actually.
exactly one time. Yeah. And if it doesn't, then we uh, no, wait a second. Oh yeah,
No, no, no.
that's
It's
yeah,
everything's
that's
right.
it. So yeah, and if it doesn't, we right. So if there is a value already in the key, so it means that we have already encountered this number previously, right?
Mm-hmm.
So we are adding one because we encountered it again.
Yep.
And if there's no such key, it means that this is the first time we encounter this number. So we put it as a key, and its value is going to be 1, right? So that's the first time of our encounters with this value.
Okay.
So, and then after that, we have our hash map field with keys, meaning that the numbers, right, that we encountered, and the number of times that we encountered them, right?
Mm-hmm. Mm-hmm.
And after that, again, we have our sum.
Mm-hmm.
And well, that's a little bit more easier then. So we have our first column with the numbers. And if our hash map contains the value from the first column, right? Uh, then we get the value, and then we multiply this value by by the number, right?
By our number in the left column, right?
Yep. And
Mm-hmm.
we're adding that to the sum, and then
Yes.
we're
And
returning
then
the sum.
we are returning the sum.
Yep. Right. So that seems quite easy, right?
We
So
should
let's.
change our main a bit to demonstrate how it works, I
Yep.
think, right?
Yeah. Exactly. Right.
Yep.
Okay. So we have here day one. Get some part two, and that's the nums again. Right. And let's comment it
Yeah.
out. Yeah.
Well, you
Well,
can launch it. It's very fast, actually.
oh, yeah. Let's do
Let's actually. I think it's very interesting. Let's uncomment this line,
it.
and
Okay.
show how fast it is, even when it performs both computations. It's
Super fast.
blazingly fast.
Yeah.
Yeah, I mean, you can't even notice. And it's what I like about algorithmic programming, actually. Usually, when you write some algorithm for a problem that seems very hard, the algorithm is still somehow very fast. Like, again, I'm solving this advent of code for many years already, for multiple years already. And sometimes I am trying to write a brute force solution for some problem.
Hmm.
And solution takes minutes, sometimes hours to finish. This essentially means that, well, that I didn't try good enough. I should I should optimize something, and then it will suddenly become blazing fast. For today's problem, today is the day 6. I encountered, it's the first time in this year when I wasn't able to solve the problem without making mistake in my code. And the first solution took like 30 seconds. And then I optimized it a little bit, and now it takes around 3 seconds. I'm not sure we'll have enough time to jump into it, but well, maybe let's look at day 2.
Yeah, day two, maybe, or maybe. So what was the day two? Gosh, I forgot. Maybe we should show
It was
something interesting.
they were rows of valid and invalid rows.
Uh, these ones, right?
Same. Give me a sec.
I thought you wanted
Yes,
to
this
show
one.
the one with the grid, with your beautiful grid.
Oh, okay. I think it's day 4.
Yeah. So let's look at
Should
grid.
I show it? Do you want to show it?
I think it's better for you to show it because
Okay,
then,
go.
yeah.
Okay, no problems. So first, let me share the task itself with you. Um, so I'm yep, somewhere here. It's day 2. Let's jump to day 4. Again, there is this whole nice story about elves and chefs and so on, but currently we are interested only in the task itself. The task is kind of simple. There is this field of letters, of characters, X, M, A, and S, and they obviously form the word Xmas, whatever it means.
For
And
Christmas.
our goal is to find, well, actually, to find Xmas inside this grid. Here is one example how it can be located, but it also can be located like diagonally. You can see X, M, A, S. Or, for example, it could be written right to left.
I'm sorry, Pasha, to interrupt you. It's
Yeah.
totally off topic, but do you think Xmas for Christmas is well? They chose X for Christmas because X symbolizes like kind of a crucifixion.
Yeah,
Yeah.
probably. But Xmas is very popular abbreviation. Is it
Yeah.
abbreviation? Yeah, I
Mm-hmm.
think it's an abbreviation of the word Christmas. It's just
Yeah.
easier to write, and obviously, it's much easier to solve this task
Oh
when
yes.
there are only 4 letters and not
Yeah. Mhm.
8 of them.
You're absolutely right.
Well,
Okay.
solution would be essentially the same, but it will be unnecessarily. It would take unnecessarily more time. If you can solve it with Xmas, you can solve it with any other word too, obviously. So, how do we tackle this problem? Um, I have my own solution, and I have actually a class that helps me solve this kind of issues. Let me share my idea. Yeah, something like that. Whoop.
Okay.
Is it readable?
Yep.
Okay. So I have a class called Grid,
Oh, now it's
and
too small.
since the time when Katya, now it's too small again. Give me a second. Now it should be better. I hope. Is it?
Yes. Mm-hmm.
We'll refactor it right on point. So compared to last time when Katya saw it, it has 2 fields now, not one, and we are not interested in this one. But it stores all the data about our grid in map, where and map of this key is point to D. Point to D is kind of straightforward data class. My solution is in Kotlin, but we can actually switch to Java.
Well, we can look at both. I mean, you said that Kotlin is a little bit more concise in some ways.
Yeah,
Tasks.
I'm not sure that this is the best task to demonstrate it actually.
Okay. Okay.
So yeah, let's look at this one. Why? No, wrong class. Yeah, not right class, correct class. So it's a map of J point to D to something, which is stored in grid. In our case, it will be character, but can be obviously anything else. J point to D is a very simple record, which contains 2 ints, x and y. Also, it allows us to perform operations on points, uh, add them, and multiply them. It's a little bit of linear algebra for you. Like, imagine that you have a vector which goes from point 0, 0 to point 1, 1, or should I put it this way? Yeah, to point 1, 1. How do we make it to go to the point 2, 2, 2? We should add one more vector, 1, 1 to our first vector. And this is actually what our class tells us, our function plus tells us. We create a new J point to D, adding other x to our x and other y to other y to our y. And a very similar thing happens to multiplication. We can just make our vector longer. Point and vector are essentially the same. Point to D is vector starting at 0.00 and ending at the point xy. And multiplication works essentially the same way. We can multiply, in the same example, when we need to go from 1, 1 to 2, 2, we can multiply our first factor by 2. And this is essentially what we do. We multiply our j point to d by integer and return a new point, j point to d. It's only two functions we will actually need for this whole task from point to d. Now let's talk about grid. We are not interested in this part, and actually not in this part. We are interested in getters mostly. Getters allow us to get data from our grid either by x and y coordinates or by j point to d. And it works pretty straightforward. Data is a map, so we just get the data from map by its key. We can also set a value at some point. We can check if our grid contains something. And very interesting thing is this function beam. It's not what you usually think about in grids, but imagine the situation when you are standing in some point on the grid and you need to read multiple items in one direction from this grid. How would you do it? Well, you will actually have to write a beam from one point and to infinity. In our case, it doesn't have to be infinity, but it can be infinity if you want. We have this source point. Let's imagine that it's our x. If we are talking about our task, we should draw a beam from x to next three letters, next three characters, and they should equal to MAS, right? So then we have a vector for direction and how many items we want to gather on our beam. Then logic is very straightforward. We just create a range from 1 to our amount. Then from each of these, for each of these points, we create a new point. We filter if we check if this point is still on the grid. If it's outside the grid, we are not interested in this point. And then we just return the data from our grid by point. Uh, I forgot to mention something. Yeah, directions. Directions. I have multiple directions defined in my class, up, down, left, right, and diagonal ones. Up is 0, -1, and it's kind of counterintuitive because in school, when we learn our linear algebra, or when we algebra at all, uh, y scale is going positive on the top. But in our case, if you think about how arrays are structured, then, and we have array of arrays, like this is one array, this is another array, this is another array. And we are standing on the line number 2, and we need to go up. What is up when we imagine it? It's -1. And this is why our coordinates are inverted, contrary to what we wrote, what we drew in our, how is it called? School pens. Yeah, so obviously I have these directions defined for all 4 main directions, for the up, right, down, left, and for diagonal ones. I also have this list called directions, obviously, which I just use to store all the directions, to not define this list everywhere where I need to use my grid. Now let's jump into our solution.
Right, yeah, so that was a preparation,
Yeah,
right?
this is
So, and yeah.
the explanation was very long. When you understand the concept, it takes you almost no time to write the whole thing. I think I wrote the whole grid and j point to d thing in maybe 5 minutes. And many people have the same grids from year to year, because you actually reuse the same structures if you solve in the same language, or you can re-implement the same structure in a different language if you're not familiar with it. This is my main function, which just tests. This is what I was talking about, error messages and so on. I test everything on a test input, but we are interested in this part one. So this part one obviously accepts a list of strings. Then we create a grid from our input. Nothing interesting here, in my opinion at least. It's just a JGrid of character. Can I? Oh, come on. macOS is tricky. It's always smarter than me. Whoop. So the next thing I do is I iterate over all the points on my grid. It's just a fancy way in Java to say that I want to iterate with streams over something iterable. For each point, I check if this point is X, because if it's not X, I'm not interested in it. I am looking for what's Christmas, Xmas. It starts with X. If it actually starts with X, then for each direction I have, you remember them, up, right, left, and so on, I create a pair of points. First, our starting point, our X, and second, our direction. Then for each of these pairs, I create a beam of length 3 from my source point in my direction. Then I just concatenate them to a string because Java is very verbose again. And I should have MAS and it should be Xmas. And then I count all the entrances of this word.
Oh, that
Let me
looks
launch it for
beautiful.
you. How fast is it? Well, it should start Gradle, so this part is definitely long. The task itself should be relatively fast. Let's see. Whoop. Oh, we are compiling. Nice. Yeah, it's the first time I actually run all these tasks
Hmm.
on this machine because I usually work on another one, not that fancy as this. Oh,
Oops, something went wrong.
yep, definitely something. That's why I
Okay.
live coding. Yeah, right. Of course, I forgot to save all my inputs.
Oh.
Should probably think better. Okay. What is it? Um, 040 src new file 040.txt. Nice. This is my test input. Um, this is my main input. Do you see when I'm doing
Yes.
something?
Yeah.
Cool. This is my main
Right. So
input.
yeah, you
Let's
can
run
see
it
that's
again.
very freakishly big.
Well,
uh,
it's actually it's not that big. It's only 140 lines, and it's
well, it looks
140
it looks terrifying.
140 characters in each. So it's it's under 40,000 symbols in general. It's very small, and you can see well that I took all the results almost immediately, almost instantly. I actually tried to build the whole thing with a GraalVM native image,
Oh.
community edition, not the enterprise one, and it was suddenly even slightly slower. I don't know why. I do not make
Well,
any.
somehow I really don't know too, but sometimes Rural VM Community Edition is slower than Java. But we know that it has good performance, but not as good performance as Java itself, as the JVM.
I cannot
So,
say anything like that. I think I mean I just can't. It's a very strong conclusion which I am not qualified to do.
well, yeah, yeah.
So yeah, it's just an interesting observation that for me in this particular scenario, run like 2 times, native image was somehow slightly slower. Okay, and then we jump to the second part. Let me share the task again.
Mm-hmm.
Screen day 4, nice. Here we go. So it turns out that elves mixed up something, and we are actually looking not for X mass road like this, but at X mass, which is MAS road like a, like a cross.
Yeah.
Here is one example of how it can be written, like A, and we can see MAS like this, and MAS right here.
Yeah, so as you can see, there's no letter X, right? But we
Yes,
have mass and mass, and they form an X.
yeah, they form the character X, and here we have all weird kinds of con- MAS concoctions, like this. Almost every S is reused twice. This S is reused in two masses. It also shows us that, for example, they can be heavily mixed like this and like this. I mean, almost any way. But if you think about it, we already have everything we need to solve this task. Yeah, that our task is obviously how many times does an X mass appear. So how do we do it?
Oh,
Let's just discuss the theory. How will we
yeah.
do it? How will we tackle
Okay.
it? We look at two diagonals around every A, and there should be SM on the one diagonal and SM on the other diagonal.
Mm-hmm.
We already have all the methods we need to access these diagonal values. So theoretically, it should be very easy. Take one of them, take another of them, put them together, sort them. If there are two input, if there are two MS inputs, then we are done. Well, we are there.
Yeah.
If it's something different like MAM and SAS, then we will have two inputs like MM and SS, and this is not what we need.
Obviously.
When
Yeah. Yeah. Just.
I
Uh,
mean, to me, it's kind of intuitive. Let me share my ID again. I will probably find it one day. Yep, here we go. First, we start absolutely the same. We convert our input to grid. Then we iterate over our grid. Now we are looking not for x's but for a's because they are the center of our virtual crosses. Yeah, I have one more variable or value I didn't show you. By the way, it's interesting. Can I do it like this? Is the load in Java? Var. No, it's not load. It's
oh.
not local, so it's not load. What a shame. So, yet, to not think about what diagonals actually are, I just put them right here. I know that down left goes opposite to up right, and up left goes opposite to down right. And this knowledge I use in my solution start from A, uh, then for each pair of these opposite directions, gather points on these opposite directions, sort them, convert them to string, and there should be two of them equal to the string ms. And this is actually our solution. This is a huge chain to achieve this simple goal. And when I run it, let's check it just in case. 8031. Whoop. 8031 was the correct answer. Let me, since we already know the whole theory, let me show you how I solved it in Kotlin
Yeah.
just for a comparison.
Let's look at Kotlin. I'm not a Kotlin user yet, right? But since I've met Pasha, I well have increasingly felt the I have been inclined actually to learning Kotlin because what Pasha usually does, he shows me some code in Java. And then he shows me some code in Kotlin and says, "Look, how much more
This
convenient
is
it
the
is."
same I will do right now.
Yeah.
Because the solution of part one looks like this. I take grid, convert it to sequence, filter all the characters by X, and I, again, I find all the directions because I have them in my variable. For each pair of point and direction, I create a beam from point in direction of size 3, join them to string, which surprisingly can be only one call instead of three in Java. And then I compare them to MAS. And well, it's the whole thing. I think we can count symbols, and I think I think Kotlin will win because what's it? Even in lines of code, it's from 54 to 65, 11 lines of code. In Kotlin, it's from 7 to 15, 8 lines of code, or something like that. Maybe I made all by one error again. And regarding the part two, should be something very similar. Find the points which contain A, opposite directions, map. This part cannot be really much shorter than in Java, but again, I can just join them to string, filter, sort, join to string, and check how many of them are MS. There should be two of them equal to MS. I actually think that this is not too impressive in Kotlin. I think that day one in Kotlin is much more impressive because there were there was a lot of magic for even to solve the part one. Whoa. And here it's like this. Pairs split by space, filter, not blanks. Then each of them, wait, it's parsing. Sorry. Yeah. First we parse and then we sort first column,
Mm-hmm.
create first column, sort for first column, create second column, sort first column, concatenate two columns, and some differences of left and right, absolute differences of left and right.
Oh yes, that is more laconic.
I mean, yeah, I mean, this is so much shorter, and it happens for almost every task. Kati didn't show you a lot of other interesting things, but for day two, solution in Kotlin is essentially this small function, which still contains loops, and these two lines.
Right. So,
Uh, yeah,
yeah, Pasha, maybe we could look at the task of, well, today's task, because you said that it was more.
we can. I'm slightly worried that we are almost out of time, but maybe just let's not look at the code. Let's look
Okay.
at the idea, what they're asking for, and make a conceptual solution.
Okay, let's do that.
I share the wrong thing. Share screen. Yep, yep. Somewhere here. Day 6.
All right.
So we have this map, and on this map there is a guard who looks up, and this guard will go up, and when it will hit this hash, it will it will turn right, and when it will hit hash, it will turn right, and so on and so on and so on until it will leave the map.
So
And
every time he hits the hash, he turns right.
yeah, he
On the right.
turns
Okay.
right
Okay.
until he leaves the map.
Okay.
And our task is to count in the first part to count how many points did he eventually hit until leaving the map. It is actually, again, it's a very simple task when we have our grid, because it's just a question of adding a correct direction to our point every time. First, we find a point with our guard, and we know that guard always looks up at the beginning, and we just add. So our point plus up, plus up, plus up, plus up, plus up, plus up,
Okay.
and we count all the visited points. We put them in a hash set or something
All right.
until he leaves the map. That's
Okay.
all. That it's 41 on the test input, 41 item on test input, and it's what was it?
Uh, There was
It's
at the
5,000.
bottom there was 1,000, or that was a part two.
Yeah,
1,060.
5,000 something. So the map is relatively big. I think it's around 140 lines. I'm not even sure where is our guard here. Give me a sec.
Um,
Yeah, here you go. Here is the guard. Obviously, at this point, it's impossible to manually trace. So we will have to write a program for it. And the program is very simple. We just add the direction every time. But then the second part comes in and says, okay, now the task is slightly different. We want to add one more hash somewhere
okay.
to make the guard go in loops. And loops can actually be complicated. And even for a test example, there is how many 6 different positions where we can put our new obstacle for our guard to walk in loops.
Mm-hmm.
And this is the part where I made a mistake. I didn't understand that actually there is a possible situation when guard can turn twice because he makes his move, hits the wall, turns right, and there is a wall again because we just put it there. And this is the small part which didn't allow me to solve this task from the first try. I actually spent quite some time on figuring out what's going on, and I think that eventually the whole task took me like 40 minutes compared to 10 minutes yesterday. And the solution here, it's possible to do in 1,686 times on my input. On your input, it will probably be different. At this point, I think it makes sense to make a small summary.
Okay, let's do that.
Katya, what did you learn from Attentive Code?
Right. Well, first of all, I learned some useful tricks in IntelliJ. Um, I uh, I think I got better grip on gatherers because they were required for some tasks. But the most important thing is that uh, Advent of Code teaches us to, well, think analytically, right? That's not what you usually do, I think, in life, right? So we see the problem, and we have to think about the possible ways of solving it, right? So we have to think about the solution, and that's, well, the tasks. The most important thing is to imagine the solution in your head, and then think how you can solve that, well, how you can achieve this solution in your chosen programming language. But first you should think in a more abstract way about the solution, so how it is possible to solve it.
I like this explanation. I also want to say that the whole event of code is about being exposed to different concepts. And sometimes it's impossible to find such a context on your own. Sometimes you'll have to Google, sometimes you'll go to Reddit to read about it. And well, it can be tricky. It won't kill you, but it will eat significant amount of your time. But when you're exposed to it one time and when you understood it, you actually can reuse it, this very concept, many times in other tasks. Like it happens with this grid. I reuse the same grid for multiple days, for day 4 and for day 6, and probably for all other days. And I have multiple functions implemented on top of this grid, for example, grid rotation and so on. They're so simple when you have a right abstraction. And this is what we actually have in our life. When you think about it, all the libraries we use every day are that popular because they have beautiful API. Somebody actually invested the time to create a nice abstraction for you that you can reuse every day almost without thinking. And that's what I do with my grid, and that's what the Spring team does with Spring if you use Spring and if you use Java. The API is just beautiful. And many other things. The Kotlin for me is also about beautifully designed API. So my call to action is please go and try to solve Advent of Code puzzles. If you do not know how, try to read something on the topic. Try to read something, I don't know, something in Reddit, something on Google, somewhere. There is a lot of information. And then try to understand what other people do and recreate it on your language of choice with your technology of choice. And this actually will make you a better programmer, almost independently of how good you are right now.
Oh yeah, that's a very beautiful call to action. Pasha, do you care to share your GitHub so maybe our listeners
Oh, we could. I
yeah,
absolutely
follow
can.
this?
Let me try. I'm actually not sure how to do it, but my.
It's a little bit
We also have
small.
this. Give me a second. Nah, we don't have them.
All right, guys. So this is the first time that me and Pasha join here in a live stream from
Ah,
BellSoft, right? So that's a new platform, new experience. Well, not exactly new because Pasha and I have visited other live streams, but this time
this
it's
is
still
how
very
you. Oh,
different.
sorry, Kate. Sorry, Kate. This is how you can find my GitHub. I actually do a lot of on GitHub. I do pull requests to third-party projects and so on. Open source is a part of my life. Uh, yeah, it is as well as BellSoft Live. Other than that, you can follow us on Twitter. I'm almost sure that. Whoa, but it's interesting. How do you think? Can they click this link? I think they
Um,
cannot.
well, I can. I actually
You,
can.
of course, you can.
Oh, okay.
Yeah.
Well,
So my my handle on Twitter, and I won't call it X. Do not expect me to call it X.
no,
Is
never.
Asmodio, and Kate will write her in the chat.
Yeah,
Can you write in the chat?
sure, sure. I actually hate it when people call me Kate because I think it's so banal. I don't know,
Well,
somehow I have.
sorry.
Yeah, that's
Do you
okay.
prefer Catherine?
Catherine or Cat? You can just call me Cat. I mean, I know it
Yeah,
might feel
well,
weird because that's
the
well,
difference is
meow.
very subtle.
Yeah, but still, Cat is a little bit different than Kate. Kate is just like Jane or Kate. Well, I
Yeah,
have this
okay.
thing about
I got your point.
yeah.
Folks, thank you very much for being with us. You are amazing. I hope to see you the next time. Probably I won't fuck up with the stream next time. And well, see you soon.
Yeah. Bye, guys.